Okay guys, so the next thing that we wanted to do here was to determine what the soil pH was. Now, back at the creek we were measuring the pH of the water using a glass electrode, so something that we could put into the water and make a measurement. We could take some of this soil, mix it up with some water and put that same type of glass electrode in and measure. This is just another different way of determining soil pH, and the beauty of this is that it's using a very simple set of kit, that you don't have to have a good battery, you don't have to have an electrode that works. This stuff can sit in your car for months or years on end and you can use it whenever you need it. So what I've got here, samples of soil, surface, and then samples down the soil profile. I've already prepared these ones, but I'll do one just to show you the process. So what I've got here is an indicator, pH indicator solution. So you're very used to these one way or another. Litmus paper is a pH indicator. Phenolphthalein, remember the one that's clear or goes pink? That's another pH indicator. But those pH indicators are just telling you one change in pH. Okay, litmus paper is telling you it's either alkaline blue or it's acid red. Phenolphthalein telling you the same. It's one single pH that you can say, okay, I know what pH it is, it just changed colour. Whereas this is a mixture of indicators. So multiple different indicators with different colour changes, so that we get a set of colour changes throughout the pH range. Okay, so I'm just going to put some of this indicator solution on my soil there. Okay, so I'm just adding a few drops till I can get it wet with indicator solution, and then I'm just going to mush this up so that the indicator solution can react with the soil, can reach the colour that reflects what the pH of the soil is. And I've done the same with all of these. They've all been stirred up so that the indicator's well mixed with the soil. All right. So the indicator has now taken on the colour that's appropriate for the pH of the soil. But because this soil is dark grey, I can't see what that colour is. Okay, all of these are dark grey soil colour. You can really just see wet soil. You can't see what the colour of the indicator is. So the next step that I'm going to do is to take some of this white powder. So this is barium sulfate powder. The characteristics of barium sulfate are, firstly, that it's very, very white, so pure white. It doesn't absorb water, so it stays as a nice powder in the bottle. It doesn't change the pH, okay, so it won't change the pH of these because it's extremely insoluble. So in other words, it's just going to be white, inert powder that goes onto the top that the indicator solution can then soak up through. So we're seeing the colour of the indicator on a pure white background. Okay, so you can see I'm just spraying a bit of this white powder on each of these. I don't have to cover the whole lot, I just need an area where I've got good coverage so we can see the colour of the indicator solution. Then I'm going to use this little card. So this is a card with a range of colours on it. Okay, so you can see the various colours there. A card, you can see there's a range of colours on here, and beside each colour there's a number. That's the pH that we would see that colour at. Okay, so this is showing you the range of colours that the indicator solution can take on when it's exposed to soil of different pHs. So I'm just going to use this little card to compare with the colour of the soil. And so I'm looking at that and I'm saying that colour of the soil is very close to 4. If I look at 4.5, no, the colour is too green. And as I look at 3.5, I'm saying, no, that colour is too orange. So the colour of the indicator on this particular piece of soil is somewhere around 4. Okay, so we have reasonable accuracy there. We know it's not 3.5, we know it's not 4.5. It's somewhere around 4. Whereas this one is much greener, okay, somewhere around 5. So 4 at the surface, 5 by about 15 centimetres down. This is about 30 centimetres down, and it's even darker green, so much closer to that 5.5 value. And then as we get even further down the profile, that's looking somewhere around 6, maybe 6.5. It's definitely not 7. 7's too green. I think somewhere around 6. So 4 at the surface, 5 at 15 centimetres, 5.5 at 25 centimetres, and maybe 6 at 35 centimetres. So using this very simple technology, we're able to get an assessment of how acid or how alkaline the soil is. And in this instance, we can see that it's quite acidic near the surface and heading back towards neutrality, okay, down the profile as we get deeper.